Hello everybody, welcome back. Today we're looking at 2.3 angles and angle measures. These outcomes are from, they've been moved from the Pre-Cal 12 to the Pre-Cal 11. So these are in your textbook on Pre-Cal 12. So it's 4.1 from Pre-Cal 12, but we just call it 2.3 to continue with Chapter 2 for trig. Okay. So angles can be measured in degrees, where 360 degrees is one full rotation, as we talked about in one of our previous lessons. Rotation angles in standard position. Remember that the initial arm is on a fixed, goes through the fixed point on the vertex. It's the positive x-axis for the initial arm. All right, and the angle formed between the initial arm and the terminal arm, that is called the rotation angle. And again, remember, it is on the right. It is said to be in standard position, the positive x-axis, okay, when we're talking about a coordinate system. All right. So again, this is a little refresh from previous lesson. Example 1, sketch each angle in standard position. So we would start on the positive x-axis. We would rotate through. Here's 90. And then we would go a little more, 20 degrees here. You can use a protractor if you have one. And it says state the quadrant. This is in quadrant 2, right? 1, 2, 3, 4. Angle 150, so same thing, it's in quadrant 2, so we go right here to 90. Remember, start on the positive axis, up here to 90, continue through in quadrant 2, 60 more degrees, leaving 30 as a reference angle, and a little more than half, right, when you're just sketching. And again, you can use a protractor. Next one is 400 degrees, so we go all the way around 90, 180, 270 to 360. Right, and then we add in 40 more. All right, so slightly less than halfway on the diagonal here, right? And that is in quadrant 1. Okay, and the reference angle would be 40. And you remember I showed you in the calculator that if you took the sine of 400 and the sine of 40, we'd get the same. And we'll talk more about that. That's where we're heading in the next section. Negative 500 degrees, so this means we go in a counterclockwise, or sorry, we go in a clockwise direction. So we started quadrant 4, quadrant 3, quadrant 2, quadrant 1, back to where we started. So that's 360. So we need 140 degrees more. So another 90, and that would take us to negative 450, and add 50 more, slightly more than halfway through, more than 45, and we get to the negative 500, which is in quadrant 3. The quadrants still are the same. They don't change. Okay. Now let's look at when we have a point that lies on and creating a terminal angle there. So if we have a point, negative 3 and 4, that is going to be in quadrant 2. So we sketch the point, all right, and we draw the angle. There's your angle here, and then your reference angle would be there, right, when you drop perpendicular and create that right angle triangle. So this is where we're going, and we're going to talk a little bit of this later on. In 2b, draw the angle. So again, our point is negative 7, so we go left 7 down 2, right our point, draw a line from the origin through to our point. For the terminal arm, draw the angle from our initial arm to our terminal arm, and we see that that angle would be over 180 degrees. Okay, and we're going to solve that in a little bit. Coterminal angles. So coterminal angles are angles that have the same terminal arm, hence coterminal. All right, and there's an infinite number, obviously. If you get a coterminal angle, you literally just add or subtract 360 degrees, right, and that'll land in the same spot. So if you look at 150, so the angle 150, you'll notice that I have 510 there and negative 210. They're both coterminal, because they both land in the same spot as 150 would as well. Look at B, example 3B, 230, same thing. So 230, we'd have 90, 180, 50 more to 230, right? So what I did was I went another 360 to the right, boom, and I got to 590, so I added 360 to here. 230 plus 360 is 590. And then the same thing if I subtract 360, I would get negative 130, and I go to the left. And again, there's an infinite number. You can continue to add 360 or subtract 360. Remember, principal angle is between 0 and 360. So if I gave you the angle 590, you would take 360 off that, or you would continue to subtract 360, or add 360 for that matter. Obviously, the number is larger, you would subtract until you got to an angle between 360. So if I subtract 360 from 590, principal angle is 230. These are coterminal angles, all right? But the principal angle is the angle that's between 0 and 360. Okay? So these would be principal angles, the 150 and the 230, and 510, negative 210, 590, and negative 130. Those would be coterminal angles, and the principal angles would be up here. Okay? So again, there's a little formula for that. So the measure of any angle coterminal with principal angle can be used to determine, just take the angle and add or subtract 360n, where n is an element of the integers, right? So 360, 270, 1080, in the opposite way as well. Remember the definition for a reference angle. A reference angle is the acute angle formed between the terminal arm of the rotation angle and the x-axis. So again, this is just a little review from the other day. So 150, then we just drop an angle to the nearest x-axis, right? So if it's in quadrant 2 or 3, you're going on the positive or the negative x-axis, and if it's quadrant 1 or 2, you're going to the positive x-axis, like we did in class. 150, so the reference angle is 30. All right, and all you do to get that is 180 minus 150. Next one, 285. So we draw our 285, 270 here, 15 more degrees, leaving with 75 in here. It's however way you want to figure it out. A lot of these will just become intuitive, and you'll be able to know how to do it. Next one, 22 degrees. So the angle is between 0 and 90. That is the reference angle. Next one is negative 269. So that's almost negative 270. So it's just before the positive y-axis here, 89 degrees. Okay. So a lot of that was review, a few new things. The radian measure of an angle. This is where we're going to start to learn what radians is. So all along you've been said, make sure your calculator's in degrees, make sure your calculator's in degrees. So now we're going to use radians, and you're going to see what that's used to solve for. We'll do a little bit here, just some little bit conversions here in pre-cal 11, and we really get immersed in it in pre-cal 12 and calculus, okay? So the radian measure of an angle is the ratio that compares the length of the arc, so this part here, okay, to a circle to the radius. It's a ratio. So you take the length of the arc formed and you divide it by the radius, and that's equal to the angle in radians. Okay? So let's relate this to pi. So one complete rotation is 360 degrees. So if you went all the way around here, you'd have 360 degrees. All right? And we know that 360 degrees, the arc length for the one complete rotation, as you guys know, is the circumference, right? The circumference of a circle is pi d, or 2 pi r. So I take the arc length of, if I had a whole 365, which would be 2 pi r, that's the circumference, I divide it by the radius, and I get 2 pi. So that means that 360 degrees is equal to 2 pi, where pi is 3.14159, So what is the measure of radians a half rotation? Pi is equal to 180 degrees. Okay? So 180 degrees is degrees on your calculator. If you switch your calculator to radians, if you put pi in place of every 180 degrees, they're equivalent. Okay? So that means that 1 radian, and there's a conversion factor. So if we're converting from one to the other, it's kind of like when we were doing conversions in Math 10. Whatever you want to get rid of is in the denominator, what you're going to is in the numerator. So if I wanted to switch something to degrees, and I was given a radian measure, I would multiply by 180, divide by pi, and that would give you what you need. Okay? So remember to use the degree symbol, and if it's in radians, there's no degree symbol, it's in terms of pi. So note the symbol of degree symbol. It looks like a little circle or a little O in the top right-hand corner, superscript it's called. Following a number means that the unit of angular measure is degrees. If there's no units after the number, then the abbreviation, we just usually use RAD or radians, or if it's in pi. Okay? So let's convert between degrees and radians. So in example 5, if you convert from degrees to radians, you give the answer as an exact value in terms of pi. If you can, where possible. So 120 we're going to learn is one of our special ones. So we take 120, multiply by pi, and divide by 180. We try to keep this in terms of pi. Well, 180 divided by 120 divided by 180 is equivalent to 2/3. So it's just like the degrees divide out if you wish, and you end up with 12 over 180, which can simplify to 2/3 or 2/3 pi. Okay, you don't need to put it as a radian measure if there's pi in the end like that. Negative 315, again, this is one that we're going to learn that we're going to use a lot, 315. So 315 divided by 180 is equal to negative 7/4, or negative 7/4 pi. You can put the pi in the numerator or denominator. That's what I meant to do here, just like in the last one. I do apologize. Okay, and then 205, this isn't a common one. We're not going to use a whole lot, but it would simplify to 41 pi over 36. Okay, so to go from degrees to radians, you multiply by pi over 180. Keep it in terms of pi if you can. If you can't, you don't need to. That's fine. Okay. The reason we like to keep it in terms of pi because it's exact. It's an exact value. That's what's nice about pi. Because pi, as you know, is an irrational number. So that allows you to keep a rational coefficient in front of the pi. But anyway, we'll learn about that as we get more comfortable. Example 6, convert the following from radians to degrees. Round the answer to the nearest hundredth where needed. So if we have pi over 4, we multiply by 180 over pi. It's the inverse, right? Or not the inverse, sorry. The reciprocal is what I meant to say. I apologize. So that means the pi's will divide, and we just take the 180 divided by 4. 180 divided by 4 is 45 degrees. So pi over 4 is equal to 45 degrees. And here's the good news. If you go to the first page of the document I gave you, all of these special ones, as we're going to learn, and we learned a little bit in 2.2 when we did cast, we have these values here. So 30 degrees is pi over 6. So there's 45 is pi over 4. And you will have this on your assessments in your exam, okay, which is good news. All right? But we really want you to get a feel for it as you're working, okay? So in example 6b, we have a negative 7/3 pi. We multiply by 180 over pi. The pi's divide give you 1. Leaves you with negative 7 multiplied by 180, which is negative 1260, divided by 3, which is negative 420. C is already, it's in a rounded answer. So what you're going to see is you're getting really close to 90, but it's not quite. And that's because that's rounded. This is actually pi over 2. Yes, pi over 2. This is pi over 2. You'll notice it's approximately half of pi. So that's why we get 90 degrees. But it's just a decimal. That's why we try to keep it in terms of pi if we can. All right? Let's look at arc length. We'll go back to that arc length that we talked about before. So remember, recall that equation I just mentioned. Radians, a measure of angle in radians is equal to the arc length divided by the radius. Or, in short, for the formula, we just use theta is equal to A over R. A equal to arc length, R is the radius. So look at this example. 7, calculate the arc length to the nearest tenth of a meter of a sector of a circle with a diameter of 9.2 and a sector angle of 150. So right away, when you see 150, you can't put that in for theta. That has to go to radians right away. And that's why radians is important when you have some of these word problems or real life situations. We usually use, we need that measure in radians. So we take the 150, multiply it by pi divided by 180, and we get 5/6 pi. You can put the decimal in if you want in your calculator, but I just recommend simplifying, and then it'll give you the exact value. So you plug this in, and you literally just plug pi in your calculator. Don't use 3.14, So we put in 5/6 pi, or 5 pi over 6, multiply it by the radius. The diameter they gave us was 9.2, so we took half that for the radius. Multiply 5 pi by 4.6, divide it by 6, and we get 12.0 meters. All right. So what's that mean? That means if we have a circle with an angle of 150 degrees, so this bolded part here, A, this is called arc length. This measure here, part of the circumference, is equal to 12.0 m. So it's kind of like similar, like we said earlier, to the circumference, but you're just taking a piece of that, right? Okay, and that's called an arc length. The last question there is a pendulum 30 centimeters long, swings through an arc of 45 centimeters. So then we just find the radius. We took 45 divided by 30, and we got 1.5 radians. And to switch that into degrees, we take 180 divided by pi. And that's it. And there's some homework questions there. It's in the pre-calc book, but that's in your Google Classroom. And we're all finished. Thank you very much.